Today in Algebra 1 we learned how to identify linear functions. Before we can do that, let's get a definition for a linear function, which is just a function whose graph is a line. Okay, so it has to be a function and a line to be a linear function. Part A was how to tell if a graph is a linear function. And the two questions we wanted to ask ourselves were, is it a line and is it a function? That's what it takes to be a linear function. Example number 1. If I draw this graph right here and I test, is it a function? Remember we tested last week or 2 weeks ago about functions by doing the vertical line test? I mean, vertical means up and down, and it only crosses each place once, so that means it is a function. And as you can see with your eyes, it is a straight line. So the answer is yes, this one is a linear function. Example number 2. If I look at this one, is it a function? Well, yes, it only crosses the vertical line test once in each place, so it is a function. Is it a line? No, it's not. So the answer is no, it's not a linear function because it's a curve. Example 3. If I look at this one right here, and this is my line, is it a function? No, because when I do the vertical line test, it touches an infinite number of times. So even though it is a line, it is not a function, and so the answer is no. And that's it for graphing. What about if we're looking at a table or if we're given some points? Okay, so if we're given some points, we want to put them on a table so that it'll be easier to check. When we're looking at a table, the question is it a constant change? Is it a constant change? Example number 4. X and y. X is -2, -1, 0, 1, and 2. Y is 7, 4, 1, -2, and -5. What I want to do is I want to list the change. From here to here, I added 1. From here to here, I added 1. And all the way down, it stays the same. To get from 1 to 2, I add 1. To get from 7 to 4, I would subtract 3. To get from 4 to 1, I subtract 3. To get from 1 to -2, I subtract 3. And to get from -2 to -5, I also subtract 3. So in each case, the change is the same, meaning it's constant. And yes, this one is a linear function. Let's look at another example. I'm going to make my x's the same as before, -2, -1, 0, 1, and 2. So I know each of those goes up by 1. Now, looking at my y column, I'm going to make those 6, 3, 2, 3, 6. If I evaluate the change there, between 6 and 3, I subtract 3. Between 3 and 2, I subtract 1. Since that change is not constant, I don't need to go on, but I know my answer is no. That one is not a linear function. The last thing we talked about was the equations and how we can tell by looking at an equation whether or not it is a linear function. Yesterday when you did the overview, you did quite a bit of work to copy that chart down from the book. So I'm not going to have you do that again, but let's just quickly review. For equations to be linear functions, the exponents have to equal 1. X and y cannot be multiplied by each other. And x and y can't be part of fractions or radicals. Now, a radical is just a square root. Okay, that means the same thing. That's just the formal term. Let's look at some examples. And there's really not any work you can show here. Instead, you're just going to have to kind of check them with your eyes, just spot check them. So if I do y equals x plus 3, the exponent of y is 1 when it's not showing, and the exponent of x is 1, it's also not showing. So the exponents are 1. There are no fractions or radicals, and x and y are both by themselves. They're not being multiplied together. So this one is, yes, it's a linear function. If I look at y equals 2 to the x power. Okay, is this one a function? Well, I have an exponent of x, and I already said the exponents all have to equal 1, so this one is a no. I don't need to follow the process because something's already messed it up. Let's look at this problem. 2x plus 3 over y equals 14. The problem here is that we've got y in the denominator, or y is a part of a fraction. So this one is also a no. The last one, y equals 12. This is kind of a trick problem because the x went away, and that confused a lot of people in class today. The reason that doesn't matter is my exponent is still 1. Nothing is being multiplied. It's not part of a fraction or a radical. So this one is yes. Your homework today is A7. It's page 300. It's numbers 15 to 24. And on all of those, you do not need to follow the instructions in the book, but just tell me yes or no if it is or is not a linear function.